final lesson in topic 3 on modeling is rapid prototyping, and this is lesson 5. So, rapid prototyping is pretty cool. It is new techniques for manufacturing over the last several decades. You can see this design that was created on the bottom left here, which with traditional manufacturing techniques would have been very difficult, nearly impossible, but we can do that nowadays with the rapid prototyper. So there's different types of rapid prototypers that you need to be familiar with. We're going to start with what's called stereolithography. And this uses, I'll read through it first and I'll walk you through the picture. Creates 3D models layer by layer, hardened molecules of a liquid polymer using a laser beam, additive manufacturing, or 3D printing technology. Okay. If we look down at the images down here, this first one, there's a platform, and there's just a little bit of the liquid polymer over the platform. It's submerged enough, there's a little bit. The laser zaps that liquid polymer, which is a liquid plastic basically, and it hardens. Then this platform drops just a little bit, some fraction of a millimeter, and the laser zaps it again. And it drops, and it zaps it again, and drops, and zaps it again, until from the bottom up, it has created the finished product, which is now hardened plastic. Stereolithography. All right, laminated object manufacturing. I've never actually seen this, and I think this might be more old school, but it's still in the curriculum, so let's look at it. LOM, laminated object manufacturing, basically takes a sliced CAD data from a 3D model and cuts out each layer from a roll of material using a laser or plotter cutter. Then these sliced layers are glued together. So for example, you have a roll of some kind of material down here. It stretches out across here, some laser cuts it, and then this level, it's showing the platform pushing up. I don't see that would actually work. I would see that the platform would drop down, and then it rolls over new material and cuts that new material. Then it drops down a little bit more, and it rolls over new material and cuts that. Until the end, you get what we see here on the left that's being pulled apart a little bit like an accordion. But basically, you have a finished product that is a whole bunch of really thin layers stacked together. And if they're stacked tight enough, you get a nice looking product. To me, that sounds like a whole lot of wasted material, because when you cut out what you want, everything else is just waste. Fused deposition modeling. This is what you guys are most familiar with. Okay, the MakerBots, the Cindos that we have at school, those are fused deposition modelers. These are additive manufacturing because you're starting with nothing and you are putting down layers of material. A plastic filament or metal wire is unwound from a coil and supplies material to an extrusion nozzle. It's controlled through its CNC, which is computer numerical control, controlled by CAM, which is computer aided manufacturing. Selective laser sintering is very similar to stereolithography that we saw in the first technique, except instead of using a liquid polymer, in this case, you're using a plastic powder. So they're going to take, initially this piston would be all the way up at the top here, and this roller would go over it and smooth out a very thin layer of plastic powder, and the laser would zap that layer and harden it, and then the piston would drop just a little bit, and the roller would come smooth out a new layer of plastic over it and would zap it, and again, and it would work its way down. So similar to the other one, you're going to end up with a hardened plastic finish. So additive manufacturing technique uses a high power laser, example, carbon dioxide laser, to fuse small particles of plastic, metal, or ceramic or glass powders into a mass that is the desired 3D shape. International mindedness. The high cost of some new processes does not allow for their rapid dissemination globally. If you look at this machine here, some kind of a big fancy mill of some sort, it's probably a very expensive machine. I would say easily could be over $1 million. And a lot of countries don't have the kind of capital to purchase stuff like that. So new techniques, new technologies take a while to spread around the world. Aim 10, the increasing effectiveness of rapid prototyping techniques in terms of both cost and speed enables designers to create complex physical models for testing.